now complete our look at, I guess, of the basic algebra skills, this idea of simultaneous equations. The elimination method is probably the most usual method most people use, and the idea is you want to eliminate one of the variables in our equations. Then you go and solve it for the other variable, and then once you've got that answer you can substitute back in and get the eliminated variable. Yeah, that's the basic idea. So I have something like that. I want to eliminate one of these variables. I need to make either the coefficient of x or the coefficient of y the same. Which way? You wouldn't write that down, of course, but what I'm going to do is I'm going to multiply the first equation by 2 and the second equation by 3, making the coefficients of y the same. Then I can do a subtraction and the y's are eliminated. I'm actually subtracting up, so I end up with a positive, doesn't really matter, but 11x is equal to negative 33. So x is negative 3. Now I can go and substitute back in. Again, whether you write the substitution step in or just look at it and work it out, that's up to you, of course. Y equals 9 then is our answer. So pull the answer together. There it is. X is negative 3 and y equals 9. It doesn't work so great for ones like this. And that's where the other method, the substitution method, works better. And so what you do here is I'm going to make y the subject in the first one and then substitute that into the second one. So again, I have eliminated, if you like, the y. But I end up with a quadratic for this one, and it factorizes nicely. I get 2 possibilities for x for this one. So now I have to substitute back in to get the 2 possibilities for y. My final answer, I definitely don't leave it like this, otherwise there's going to be ambiguity here. Hang on, am I saying x equals 5 and y could be either of these two? Or, no, it's very specific. It's this combination, x equals 5, y equals 4, or this combination, x equals 41 on 3, y equals minus 40 on 3. Well, what about this sort of simultaneous equation? Now I've got 3 equations and 3 pronumerals. You see, anytime you've got the same number of equations as you do pronumerals, it has to be possible to find the values of those pronumerals. Unless, of course, one of those equations is just a multiple of one of the other ones. I will create new equations. I'm going to create 2 pairs of 2 equations and then eliminate the same variable from both. So if I multiply the first one by 2, then I can eliminate the x's by matching it with the second one. So I can get rid of the x's. And I now have this new equation, 7y minus 6z is equal to minus 38. Now if I pick another pair and eliminate the x's from that one as well, so now I'm going to multiply the first one by 4 and I'll match it up with the third one. I can now eliminate the x's and I get a new equation, 3y minus z is equal to negative 10. I now have the traditional type of simultaneous equation that we're used to seeing where there's just 2 pronumerals, 2 equations. Let's solve those 2 simultaneously. I've made the z's the same. I've multiplied the second one by 6, and that now gives me that y is equal to negative 2. And now all I've got to do is work backwards, and I can work out all the other ones. So if y is negative 2, substituting that into one of them, I get z is 4. I now know y and z. Substituting it into one of the first equations, I now get the x value. So x is 3, y is negative 2, or z is 4 is our possibility. What we've actually just done there is actually, because what's simultaneous equations if I think about a picture? Now when it was 2 pronumerals, we were talking about lines on the number plane. And basically we were finding the point of intersection of those 2 lines. So what is this one doing when I've got 3 pronumerals? It's still the point of intersection of 3 lines. Now it's in 3 dimensions. And so you could have lines in 3 dimensions where they would meet at a point. Okay, 1G.